Hello, my name is Abhishek Zamre, and this is a video presentation for the Weebly's Data Engineering Take Home Challenge. So let's get started. Here is the list of the topics I will cover in this presentation. First, we will go through the project requirements. Then I'll discuss what are the potential scenarios for this project and the assumptions I made after going through the problem statement and having a discussion with Weebly team. Then we'll look into the project architecture. Basically, we will see what are the main components, what is the data flow, what tools and technologies are used, etc. We will also discuss why I selected these technologies for this project and what are the trade-offs. I will also cover what anomaly detection techniques I have used, and we will go over the basic idea behind those techniques. Similarly, I'll also go through what kind of data analytics I have done and behind the scenes of those techniques as well. Then we'll have a live project demo in which I will provide the input files to the data pipeline, and we will see how these files get processed and loaded into the database. We will also see the analytics dashboard where we can see different insights, and then finally we will see how this setup will look like when the data volume goes into terabyte or petabyte in size. We will cover both cloud-based infrastructure and in-house infrastructure as well. Okay, so requirements of this project were divided into three phases. First is to build a data pipeline where you have some files. You provide those files to our data pipeline, which take these files and loads them into the database. The second phase is to detect if there are any anomalies in the data, or if is there any data cleansing needed to be done. And the third and final step is to gather data insights and displaying it on the dashboard for the end user. Let's look into what are the scenarios and assumptions I have made during this project. So first will be there will be an external process which will extract data from the application server, and how this data is transferred from application server to our warehouse server is out of the scope of this project. We will be performing batch processing and not real-time stream processing, and data dump from the application server will be available on per day or per week basis. We can schedule our data pipeline program to continuously check if data is available for a given date, and as soon as it is available, all the activities will be performed. We are also keeping integrity constraint out of scope for now. Now let's look into what tools I have used for this project. First, for pipelining, I had few options such as Oozie, Azkaban, Airflow, and Luigi. I found the learning curve of Oozie and Azkaban was relatively steep, and these are XML based, so I decided to skip them. Now I left with Airflow and Luigi, and I found that Luigi is there from a long time and have a pretty good community support as well. So if I ever get stuck, I could find a good amount of online resources. About Airflow, it is yet to be fully mature and has its quirk. So I decided to use Luigi for data pipeline. Uh, I think there is no need to discuss as to why I chose Python. For database side, I had few choices such as Apache Hadoop ecosystem, MySQL or Postgres, and other database open source databases as well. But then after discussing with Weebly team, it turns out that Hadoop could be an overkill for this project. So I left with MySQL and PostgreSQL. And in my personal experience, when it comes to read heavy queries, Postgres is quite better in terms of performance than MySQL. So I decided to go ahead with Postgres. And for analytic dashboard, I earlier used Metabase, so I decided to use that for this project as well. Finally, for ML and analytics stuff, I used Python libraries such as Pandas, NumPy, and MLXtend. Now let's quickly go over database schema as well. For data warehousing, it's always good to use star schema when it comes to dimension modeling. I found that the provided tables reflect a similar pattern, as we have invoice table as a fact table, and we have customer info and product info as a dimension table. I decided to add one more dimension table called invoice time, which will contain a breakdown of date into columns such as day, week, quarter, and year. I added two more tables called association rules and invoice outliers. The idea is to maintain these tables so that we don't have to query our database every time we want to know these measures. We can just keep updating these tables as the new data comes in. To be honest, this can get tricky, and we can consider this as a future scope. This is a high level design of the entire project. So basically we'll have a data dump which will get transformed or get cleansed as per set criteria. Then we'll load it into the database, and then we can have analytics run on to it. Now let's look at actual implementation of this project. So this is basically an entire data pipeline which we have implemented using Luigi. First, we will have a data dump in terms of CSV files. We will provide these files as an input to the pipeline. Data dump is the first task in the pipeline, which will check if dump is available and will trigger dependency tasks. This set of tasks performs any cleaning and transformation, such as column renaming, stripping extra white spaces from column values, etc. One of the tasks is generation of invoice table, invoice time CSV file as well. Next set of tasks performs loading of these process CSV files into the database. These two tasks perform activity of outliers detection and association rules generation. Once it's done, the results will be loaded into the database, and this is the final task which will notify the end result. And yes, the result can be viewed in Metabase dashboard once it's done. Now let's look into what anomaly detection technique I used in this project. I have used John Tukey's interquartile range rule to detect outliers. The idea is to calculate first and third quartile. We have done this on quantity column of our invoice table. Then we calculate interquartile range and upper and lower fence on the entire dataset. This fence basically keeps the outliers outside. In our case, we have only considered extreme outliers. We can add such anomaly detection technique on rest of the data as well to detect missing or corrupted or suspicious data. As this figure shows a general idea behind this technique. These are the outliers in this case. Now let's look at one of the technique for generating data insights. We used association rule mining for this, which basically says a set of items which are like if customer who bought this also bought this item, so we can provide recommendation to the customer, or the business owner can like launch their bundle offers or something like that. For this, we generated item sets by mapping customer ID to comma separated stock code list he purchased. Then we used ML extends a priori algorithm to generate the frequent item sets. And along with that, we have also generated insights such as geographical distribution of customers, top 10 high selling items in 2011. These are the examples. Enough talking, now it's a time for a demo. Okay, so let's have a demo of the project. So first of all, we will see if Postgres services is up or not. And here you can see this service is already up and running. So next step is as a part of a deliverable, you might have get this zip file already. So we just have to extract it, and if you see, we have a user guide already there. So this user guide will provide all the instructions of like what other softwares you need to install in order to run this project. So I have all this dependency module already installed. So, so next step is to in this deliverable folder you will see this metabase directory. So you just have to download the jar from their website and only have to place it here. So I already have this their website open. So only thing I have to do is I have to download this jar file from here, and I guess this is the jar file. So only thing is we need to copy it here, so we can run our dashboard on here. Next thing is we will just start the Luigi daemon, and here we can see the Luigi is up and running. You can also keep an SQL client open just to see if things are going in the right direction. So yes, these tables need to be populated once the everything once the data pipeline is run. So as you can see, there is no data inside. So the daemon is up, our database is up. Next thing is we will also keep our metabase instance up as well. So this directory, this command you can use to start the server. So our metabase instance up and running. So yes, the instance is up and running. Okay, so the next thing we'll have to do is uh, we'll have to see if the input is there. So in this data directory, you will see you have to create a directory with this naming convention, so that when you give it to Luigi as a task, it will pick this date and it will search for this directory and it will start executing the task on it. So if you see, we have these files in here, these CSV files. So I'll just now, important thing is that when you run this script, you'll have to keep the this script in Python path as well. But for now we will just go ahead with this module, and the name of our task is, so you just have to give it here. And the next thing is give it date. So date is the directory name. As you might know, we have to replace this underscore with hyphen here, so we'll just hit it. The Luigi is now executing each task, and all ran successfully. So as we had data earlier in that folder, the dependency was already present and rest of the dependent tasks ran successfully. So we go here, and if you just refresh the Luigi UI, it should show all the tasks. Yeah, you can see here. Okay, so all tasks ran without any issue. You can see the parameter is displayed here. So if we go in this, and you can see the dependency graph as well. This will make more sense. So yeah, so this is the dependency graph for data pipeline. Okay, so we'll verify whether the tables are populated or not. So customer info is populated, invoice time. So here we can see we have broken down the invoice date in multiple columns. These are the outliers. They will not make sense right now, but you will see this is the association rules. So these are the tables which got populated. So now let's look into our analytics dashboard. So once we log in, we can see here we have dashboards mentioned here. So we can just click on it, and we can see multiple graphs and tables are populated here. So one of this is the geographical distribution of customers. You can see United Kingdom as the largest one. We have some in Australia as well, and this is a similarly. This is country wise customer count. This one of the insight is top 10 hottest products in 2011. One of this is top 10 highest grossing items. This is a pie chart with a breaking of like uh, customer counts per country. This is interesting one. This is the association rules which we generated. So it's like customers who bought this also bought this one, and we can have how much the system or the algorithm is confident about this. The next thing is we found anomalies as well in the data. So these are the invoice number, and we can say uh, this is like extreme outliers. So this invoice number has a like a suspicious amount, or you can say irregular amount of quantity in the invoice. So our script was able to pick it. So that's about it for the demo. Thank you. I hope you liked the demo. Now let's see how this setup can be scaled when our data goes into terabytes or petabytes. First we'll look into a cloud-based architecture. We can utilize services provided by AWS for this. We can use AWS S3 buckets to keep our data dump. Then AWS EMR, a service which provides a managed Hadoop framework, can pick this dump and can process it. And we will place it back into S3 buckets after the processing. And finally, AWS Redshift can pick those files and can load them into the database. But if we talk about an in-house architecture of such scale, we can use Hadoop ecosystem for this. We will place our files in HDFS. Then Spark can process these files, and finally we can use Hive and Apache HBase for analytics and storage purposes. And that's about it. Thank you for watching this video. If you have any questions, please feel free to contact me, and have a great day ahead. Bye.